So here we go. So I'm going to say something controversial right now. We look at soils and water reports not so much for managing salinity or managing fertility, but it's mainly for managing problems. And salinity is one of the major problems we have with soils and water, not just with avocados, but just about everything that's irrigated, going back to Babylonian times. And so it's managing the water for the needs of the tree, as well as for the chemistry of what the tree is seeing. And we are doing leaf analysis, hopefully, water analysis and soil analysis. And these can all lead us to problems as much as how to deal with actual issues of nutrient management. So pH is critical. California in general, there are areas of San Diego County on decomposed granite that have inherently lower pHs, pH 6, 6.5, and then after 30 years of applying urea, it's down to 4 or something like that. But in general, everything north of Los Angeles and Orange County and so on, Riverside, much of it, we're dealing with high pHs, and trying to manage the pHs leads to how we manage nutrients like micronutrients like iron and zinc. Doing a soil analysis and a water analysis is critical before you plant. In the Ventura area, we've had a lot of strawberries and flower ground come out, and people are going, oh, what do I plant? I'm going to plant avocados. And then they throw some trees in the ground, and then immediately they start having problems, because after 25 years of strawberries, or you've been growing flowers in hoop houses, there's been a salinity accumulation because there's been no rain, or the hoop houses have prevented leaching. And so, the simplest thing to do is to do a soil analysis before planting and correct, to leach the salts before you plant these little delicate trees into the ground, or to correct the pH before you plant, because it's easy to correct these problems before planting. After planting, it becomes an issue. And as mentioned, in order to leach, you've got to saturate the soil. Water moves by saturating soil. Whenever you irrigate, you saturate soil, and that causes issues with Phytophthora and avocados. So before you plant, do a soil and water analysis to know what you're getting into. And then also use the plant. The plant can tell you, if it's in the ground, is it having problems? The plant tells you, yes, I have iron problems. Yes, I have zinc problems. Yes, I have nitrogen problems. The other day I was out looking at an orchard, and I saw these avocado leaves that were about 2 feet long, and they were the darkest green leaves I've ever seen. And I said, have you done a leaf analysis? Oh, yes, we've done a leaf analysis. And it was running almost 3% nitrogen. And I said, why are you putting so much nitrogen on? So the tree talks to you. So listen to what it's saying. As mentioned, avocados are less sensitive to boron excesses, but we do have problems. And this is what boron toxicity looks like. Boron will completely defoliate the lemon tree, and the avocado will be fairly fine with high boron, but certainly boron in the soil and water can lead to problems. And toxicity symptoms do show up on older leaves, and this is what it looks like. Zinc deficiency. Okay, the plant is talking to you. This is what zinc deficiency, and it shows up on younger leaves. And you get a small leaf, you get a shortened internode in between leaves. In extreme situations, the Hass fruit is rounded. It looks like a reed avocado, but it's not a reed avocado, it's a Hass, and it should be looking like a pear. So identify what part of the tree that the symptoms are showing up on. Is it on older leaves? And it's going to tell you it's a macronutrient problem. If it's showing up on young leaves, it's a micronutrient issue. And more typically, it's a pH issue. It's not, or in the case of zinc and iron, oftentimes it's phytophthora. When you lose the roots, you lose the capacity to take up micronutrients. And often when you start treating with the phosphorus acid materials, the phosphonates, and you start getting a healthy root system, your nutritional problems can disappear. So nutrition in a tree is an integration of, climate and, do we have rainfall? Do we not have rainfall? Is it cold? Is it hot? Is it hot, hot, hot? Is it, is it the rootstock? Is it the watering, the water regime, the water quality? All these things go into affecting the nutritional status of a tree, including the toxicity levels. Most macronutrient deficiencies show up on older leaves. So this is an extreme case of magnesium deficiency. Here's nitrogen deficiency, general yellowing in the leaf. It's the older leaf that it shows up on. But it's on older leaves that toxicities show up. And here's salinity damage, salt burn, tip burn. And so you need to learn to distinguish between toxicities on older leaves and nutritional deficiencies on older leaves. And these deficiency symptoms are generic. The symptoms of nitrogen deficiency on avocado are the same as what you see in citrus, are the same as what you see in alfalfa. And so these are plants, and there's some really good deficiency in nutritional toxicity symptoms if you go to the University of Florida website, and those are for citrus, but they're equally good for avocado. Also, Yara, Y-A-R-A, the fertilizer company's got some really good avocado deficiency symptoms. So if you go to their website, you can see what they look like. So I'm emphasizing you're looking at the plant as well. And when you start seeing issues, symptoms showing up in the plant, it's too late to correct those symptoms for right now, but you're alerted to do something so that you can correct those problems later on. If you're doing water and salt or soil analysis, that'll give you a hint of what you need to do in order to prevent problems from showing up. So it's a way of early warning. And salts are a major issue in avocado because they are so sensitive. And the salts are coming from the irrigation water. Irrigation is a necessary activity that we do in avocados. This is not Michoacan, where it rains on beautiful soil every month of the year and you don't really need to irrigate. Here in California, we have to irrigate, and every time we put water on, we're putting salts on. We have to learn how to manage those salts. We're also dealing with the naturally occurring salts that are in the soil. And then we're putting on fertilizers, which are salts as well. So as mentioned, the salts that we put on are nutrients like nitrogen, phosphorus, and potassium. And we have to learn how to manage those nutrients as well, because they are a source of salts. And this is, an experience that I've had. Somebody, you tell them, well, you need to put on 2 pounds of nitrogen, and they go out and they put it on all at once, and you show up a couple of months later and you go, what in the heck happened here? And it's like, oh, we just killed our tree by putting on all our nitrogen for the year at one time. So it's, learning how to manage our fertilizer is important. So one of the key characteristics of water analysis is the measure of the total dissolved solids, the TDS in the water. This goes back to the old days when you put a pot onto the stove and you boil the water down and you measure the salt crust that formed after the liquid portion boiled away. And you'd analyze it for the calcium, magnesium, sodium, chloride, sulfate, bicarbonates or carbonates, boron, and sometimes the nitrate and potassium that was in it. So TDS is a measure of these salts that are in the water and in the soil. So here is the home lesson here. Soils and water reports are best used for identifying problems like pH, salinity, and in the case of salinity, it's specifically for chloride, sodium, and boron, and the sodium adsorption ratio, which is the relative amount of sodium present to the calcium and magnesium. So we're using these reports to identify problems, and it's really not so much to identify fertility management in the sense of how much nitrogen do I put on, how much potassium do I put on, because those analyses are well correlated to annual plants. Annual plants are getting all their nutrients from the soil in order to grow. Trees have got these nutrients stored in their stems and trunks and roots. And they've got mycorrhizae, they're out there, they're sucking up phosphorus and zinc and so on. And the soils reports are not very good. You know, they can tell you whether there's an excess of nitrate that might be present as a salinity problem, but they're not going to tell you whether those nitrates are going to be available for the tree, because nitrates change. You know, every time you irrigate, the nitrate level changes. These nutrient levels change, and the tree has a huge buffering capacity for fertility, and it doesn't respond immediately the way an alfalfa plant does, corn plant, cilantro. You know, you just see boom, you know, you put nitrogen on and you see that cilantro plant turn green. You don't see that in an avocado or other trees for that matter. I'd like to again underline sodium adsorption ratio. There are significant differences in the salinity constituents in water coming from the Colorado River versus water that's coming out of the ground. When you're north of Los Angeles, you tend to have high levels of calcium, high levels of sulfate, and lower levels of sodium and chloride. And you can have fairly high salinities, like the threshold value that Khaled was talking about, 1 decisiemens per meter, is based on waters that were being used in the riverside area, which tend to be higher levels of chloride dominated waters. And so they don't break out that constituent of chloride from the total salinity so much. So, you know, if you have high levels of calcium and magnesium relative to sodium, you can handle a higher salinity than some of those tables indicate. So here is a broad brush of what you should watch out for when you're reading your soil and water reports. Water exceeds 1 part per million boron, 100 part per million chloride or sodium, 1,000 part per million TDS. You need to watch out. You can use those waters, but you have to be extra careful about how you manage it. You cannot just be indiscriminate. You can't go out there and put on, you know, it's 15 minutes of water applied every day. It's just not going to cut it, because again, every time you irrigate, you're not only putting on liquid fraction, you're putting on salts, and the wetted front accumulates these salts. And if you're not putting enough water to move those salts out of the major part of the root zone, it's going to accumulate. And if you have a rootstock that sucks up salts, it's going to get into the tree and it's going to be a problem. So also when the sodium adsorption ratio is in excess of 4, that's when you have more sodium in your soil than calcium and magnesium, you're going to have a problem. The tendency is not to have high sodium in much of our waters and soils. They happen, you have to be aware of it. There's a lower tendency to have sodium problems in our soils and water than there is chloride. We really have to watch out for chloride. You also have to, when you get your soils report, it's the sodium adsorption ratio. It's the sodium that is on the surface of the clay particle that is the issue. It's where the calcium and magnesium, the other cations that are accumulating. So it's not absorption or absorption, it's the adsorption. And so if you're getting a soils and water report that reports it as absorption, watch out. There's something wrong with that lab. Okay. Also, just because you can measure it doesn't mean it's going to be a problem for the plant. Okay, and when I say that, this was mentioned by Khalid, how much rainfall do you get? How much rainfall do you get into the spring years? So right now, the forecast is for some rain that might be happening around Thanksgiving into December, and then nothing after that. So everything that is going to happen in that water regime in the avocado is going to be irrigation water. So it means we're going to be irrigating January, February, March, April, May, June, July until, gosh, you know, it rains next in the fall of 2023. There are years where we get rain into May. And so every time you get rain, you get a diluting, you have a leaching effect. And so the less irrigation water you put on, the less concern you need to have for leaching. So the rainfall pattern is really important because we are reliant on rain to make up for all the salts that we put on at irrigation. There are no good soil measurements of fertility in any perennial tree crop, okay? So it's not uncommon, somebody comes out and says, oh, you have low nitrogen. Well, anytime it rains, you're gonna have low nitrogen. Every time you just irrigate it, you're gonna have low nitrogen, unless you've been fertigating and you take a soils sample and you get it, and so, oh, you need to put nitrogen on. So fertility management with the soils and water analysis is not very good. It can show a problem with high nitrate. If you're getting water reports that show you've got 120 part per million nitrate, well, you may not need to put any nitrogen on at all. And we have instances of that in Ventura County and San Luis Obispo counties where there's high nitrates in the water. Okay, so leaf analysis works really well. This is a leaf analysis for citrus. I had a slide in here for avocado. I don't know what happened to it. Anyway, really it's the leaf analysis that determines our fertility management. It's the leaf that integrates crop load, weather, salinity in the water, health of the root system, and so on. So this is what we do for tree crops, leaf analysis. So, so here's a leaf analysis guideline for Fuerte avocado. And the leaf analysis integrates how much sun is coming in, you know, whether it's been a cool year or a hot year, the water quality, water management. I just heard a term, irrigation is called organized water management. So anyway, how you irrigate, the soil texture, the disease, the crop load. But the leaf analysis doesn't really tell you why you have that. it doesn't tell you that you've got high nitrogen in the soil. It just says that the tree has this level, and you have to find out why is it this level or not. Okay, so also water analysis is going to tell you whether you're going to have a problem with that water. So when you have high sodium water, or you have water that has a high SAR, you're going to have problems with infiltration. If you have waters or soils that have high magnesium, we have problems north of, well, a little bit here in Ventura and Santa Barbara, but certainly in San Luis Obispo, there's serpentine soils. In Monterey County, there's serpentine soils. These are soils that have high magnesium, and you get a kind of surface sealing in those soils that you would normally associate with high sodium. So doing a water analysis is going to tell you whether you're going to have problems. Something to remember is that when you're running, okay, typically we're putting on 1.5 feet of applied water, up to 3 acre-feet of applied water, 4 acre-feet, depending on if you're in Escondido and it's been a low rainfall year and it's been hot. For 1.5 acre-feet of applied water with the salinity 1.6 decisiemens per meter, you're putting on 10,000 pounds of water, of salt, 10,000 pounds of salt that you've got to move out of the root zone. So if you're putting on 3 acre-feet of water, you're putting on 20,000 pounds, you're putting on 10 tons of salt. So we've got to work with that water. Okay, so we do have some rough guides to water, what you need to watch out for that cause irrigation problems. Actually, you need some salt in water in order to get infiltration. There's areas on the east side of the San Joaquin Valley where you get this snow melt coming out of the Sierra it's so pure, it's like rainwater. And there's no salt to speak of in the water, and you'll get surface sealing because there aren't enough salts. You need salts to get some flocculation or soils forming clumps in order to get infiltration to occur. Well, we don't have that in any of the avocado growing areas in Southern California along the coast. There might be some issues in some of those areas around Parlier or something like that, but it's not around here. Okay. So one of the things that's been mentioned is that depending on the lab, you get some really weird units coming out. So they are interconvertible for some reason. Some people are still using part per million, which means the same as milligrams per liter. The conversion of part per million to milli equivalents, which is the atomic weight of whatever the calcium, magnesium, sodium divided by the charge on it. And so something that has calcium content of 40 part per million, when you convert that to milli equivalents, it turns out to 2 milli equivalents. So yeah, all these are interconvertible, and you'll see all manner of these units showing up, but they are convertible. So decisiemens is the same as millimoles per centimeter, which is the same as 1,000 micromoles per centimeter. And anyway, don't get blown away by whether it's in TDS or not, or whether you use 2 labs and you get these wildly different numbers. And it may be the problem with the lab, but it also could be just the units that the labs are using. And you can use these same units. This is a trial that we did looking at different mulches, and they'll actually, do the analysis not as actual content of in part per million, but in this case, they were doing it pounds per cubic yard. So if you put on a cubic yard of this mulch, you'd be getting 3.17 pounds of nitrogen. But it doesn't tell you how much of that would be available at that time. So this is one of the issues of soil and water analysis for different nutrients, is that the availability is not known. It's not immediately available, especially to a tree crop. Okay, so here is a water analysis that is required of all municipal purveyors of water. And I mean, you look at this and you go, what is going on here? And municipal purveyors are providing drinking water, and by law, they're required to report a lot of things that are not really important to an avocado grower. So they're reporting the amount of coliform bacteria. Well, yeah, you want to know something like that, maybe, but it's reporting on, you know, things like barium and chromium and fluoride. You know, that's not going to affect, well, as far as we know, it's not going to affect a tree crop. But you need to really zero in on, I mean, the color and the odor and so on. These, you know, don't get blown away by something like this when you're overloaded with information. And you know, this is often how people sell you stuff. They shower you with so much information, you don't know what's going on, and you go, oh, yeah, I get it. Okay, so learn to look at what's important. So here's a real soil report, and you're not seeing all this other stuff about rubidium and color and odor and so on. And it's just reporting on NPK, essentially, calcium, magnesium, and it shows the SAR. And I'm going to show you this same report just boiled down. And I'm looking at what things were important in that soils report. So it was reporting on the NPK. And again, unless it's nitrate and it's, you know, it's kind of an indication of what potential contamination you might be looking at, you really don't need to look at those nutrients. What is important is looking at the calcium, magnesium, and sodium, and these are reported as milliequivalents per liter. So this is the extract. One of the problems is they do these extractions at a lab, and Khaled was talking about a saturation extract. And a saturation extract is, you know, something that is done. You take a soil sample, 100 grams of soil, and you add distilled water with some extractant in it, some potassium chloride, and you add that until the soil just barely is wet, until it's just slightly glistens, and then you put it under suction and you do the extraction. Well, that takes somebody who knows what they're doing, and you know, have to sit there, and you know, it takes a while. Whereas most labs are doing what's called a 1 or 1-to-1 or 5-to-1 or 10-to-1 extraction, where you take a certain volume of soil and you add 1 equivalent of that volume of water, or you add 5 equivalents or even 2 equivalents. So you know, it can be automated. So every time you change the extraction procedure, you add more water, and so the analyses are going to come out differently. And so you need to know what the lab is doing. So one lab is going to do it one way, and so you can't really compare one lab to another all the time because they use different procedures. Anyway, they also use different units. And in this case that I just showed sodium as 11 milliequivalents per liter. You can convert that to part per million. 252 part per million sodium. Showed the boron as 0.92 and the sodium absorption ratio of 3.3. Now, if we go back to that mnemonic I showed you, 1 part per million boron, 100 part per million sodium or chloride, or 1,000 part per million salinity, you got to watch out. And so in this case, the sodium is running 252 part per million sodium. So this is a water that, or soil analysis that you really have to look out for because the sodium is high. Here's another soil analysis. Again, this is actually 5 different soils that were sent in. This was coming from Palm Springs. They ran organic matter on this one. And so desert soils are hard to elevate the organic matter because it just burns up in the heat and the water that you're applying. This shows the pH 7.5. Man, you know, most avocados, the rootstocks that we have don't like 7.5, 7.9, 7.7. You really want to correct the soil pH in that planted zone before you put the tree in. Otherwise, you're going to have serious zinc and iron, manganese, copper problems. So here were the high points on that soil analysis. And so this pH is 7.5, you want to correct. Boron is 1.7, okay? 1 part per million boron, 100 part per million sodium chloride. In fact, they didn't even run chloride on that soil. The sodium is running 169 part per million, which is in excess of 100 part per million. It's 1, 100, 1,000. You can use this water. The SAR is 3.3, which means there's a lot of calcium in there. So the calcium is buffering the sodium. So even though you've got a high sodium level in this soil, you can kind of get by, especially if you manage that water correctly. So hopefully the water that's being applied to the soil is going to be of higher quality than the soil is. Here's another one. This is another lab, and the way they report this is pH of 6.7. They're reporting the boron as milliequivalents. And so in this case, they show the milliequivalents per liter differently. You can convert that to part per million. So it's running 2.97 part per million. That exceeds the 1 part per million boron, 100 part per million sodium. Okay, the sodium here is only 32 part per million. Okay, so it's way low. The SAR is way low. Okay, when SAR exceeds 4, that's when you have a problem. So this has got a low sodium. It's got a high organic matter content. This was a weird soil. This is coming from Imi Valley, and it had been soil that had, the topsoil had been removed, and it was a sea horizon soil. It was, you know, it was barely dirt, and they'd been applying a lot of organic matter as mulch. Anyway, the high boron in this soil is actually coming from the mulch as it decomposed. Okay, another one. The water analysis. Oh, this is a water analysis, and pH is running 7.3. Chloride is 108 part per million. Okay, 1 part per million boron, 100 part per million sodium and chloride. Watch out. So this is just over that threshold level. Boron was only running 0.1 part per million. Sodium was 86 part per million. It's pushing that. SAR was low, 1.7, which means there's a lot of calcium to buffer that sodium as well. So in this case, you need to be aware of the water. The pH is 7.3. When you have a high water pH, it's hard to change the soil pH. Okay, the soil pH is what the tree sees. And if you're trying to change the soil pH with water, so you're adding acid to your water, if you're trying to change the soil pH with an acidified water, soils are highly buffered in most cases, and it's hard to change. If you want to change soil pH, number one, you want to do it before you plant. And number two, you're not going to easily do that with acidified water. You really need to go out there and actually put some sulfur down, or start in the soil in order to start changing the pH. But you got to watch out. If you put too much sulfur out, you'll convert that to sulfuric acid, and you'll burn the roots. Oh, wow. And here's another water. pH was running 7.6. You don't like to see water at 7.6. So you probably want to run some N-puric with this, or some acid. But they're running as part per million, 440 part per million chloride. Man, you're going to have some real problems. 100, 1,000. If you're exceeding a 100 part per million chloride, watch out in avocados. You're running 100, 1,000. Boron is 1.4. Your part, even though avocados are somewhat tolerant to boron, this is pushing it. Sodium is running 302 part per million, but the SIR is only 3.4, which means that there's a lot of calcium here. So even though it's a high sodium, I hate that. The SIR is not yet 4, but man, you got to manage this water because of the high chloride. And in this case, the nitrate was running 192 milligrams per liter, which converts to 43 pounds per acre feet. Putting on 3 acre foot, you're putting on 120 pounds of nitrogen. So you're fertigating every time you irrigate here. This is awful water, but this is something that avocado growers have to deal with. Okay, this is a nice report. One of the things that is kind of weird is that this is a water analysis, and it's showing the anions and cations, and it's showing a balance. Waters need to be in balance from a charge standpoint. It's showing 19.3 equivalents, milliequivalents per liter of anions, and 19.4. It's boy, that is suspicious when those numbers are so close. In theory, it's supposed to be close, but it should be something more like 19 and 19.7 or something, because you can't analyze for everything. And so when I saw that, I was thinking, oh, something's wrong here. Anyway, pH of the water is 7.4. Chloride is 164. Watch out. You can use this water, but watch out. And remember, if you're in Escondido and CIMAS is showing that you need to put on 50 inches of applied water, and compare that to somewhere in San Luis Obispo where CIMAS says you only need to put on 24 inches because it's cooler up there. It's got a longer winter than San Diego. You get more rainfall. You can handle a higher chloride in San Luis Obispo than you can in Escondido. So these are site-specific recommendations, but it's saying that watch out. You can use this water, but really get your leaching program down. 4 part per million, 1 part per million boron, watch out. So this is 4 part per million, watch out. Sodium is kind of low, 87 part per million. SIR is 1.4, which is, what happened? Is 1.4. So the sodium's not an issue. But it's interesting that the anions and cations are almost the same. When I see that, I'm a little bit leery. Something is not right with this analysis. It should be somewhat off. So here's anions and cations are exactly the same, 6.1. This is reality. This, you don't see balancing like that in reality. So something makes me leery of this total analysis. It's too perfect. Anyway, so here we're running water analysis, pH 7.6, boron is 0.1. All right, cool. Chloride is low, 60, sodium is 133 parts per million. And the SAR is 14.9, which means that there's no calcium, there's no magnesium in the water. Calcium was running 6 parts per million. Magnesium was running less than 1. So even though the sodium exceeds 100 part per million, which should tell you watch out, the SIR is 14.9, which means really watch out. You got to do something with this water, or not use it at all. Find some other source, because this can lead to sodium toxicity. Okay, leaching. Okay, Khaled talked about this. There is no magic potion for leaching. Unless you've got high sodium, calcium amendments are not going to work. There's no magnetic, there is no electronic device out there there is reverse osmosis that you can remove salt, but I mean, there's all kinds of devices that are sold to change the atomic structure of the chloride and sodium so it flows. It doesn't work. So there's 2 types of leaching, where you either irrigate in excess of the tree's needs and you leach some, or reclamation, where you periodically put more on. If you're trying to save water, putting water on that is applied in excess, 3rd or 4th irrigation, or something that can keep the salinity down, that happens all at once, rather than every time you irrigate works best. Okay, so when you have no rain, you're going to have problems with stem and leaf blight. This is a real problem. We're having a Santa Ana blow through right now. I was out, and what little fruit was on these trees in Santa Paula is now all on the ground. And after a Santa Ana, you're sucking water out of the root system, and if the leaves can't get it, you start getting bacteriospharia or leaf blight. It's a reaction to that stress. And usually you'll start seeing defoliation within a week to 10 days after a Santa Ana condition. So our irrigation systems, this is a micro sprinkler that shows the distribution uniformity with distance from the emitter. So right at the emitter, this is true of drip irrigation. Water is moved out to the wetted fringe where salt accumulates. This is true of micro sprinklers and drip. This is the wetting front where salts accumulate. And so you want to move that salt out of the root zone, or most of the root zone. So I leave you with, does gypsum correct soil pH? No, it doesn't, unless it's a sodium dominated soil. So that's it.